this is Benjamin from the Zephyr project. We are back for, I think, what's our fourth episode of Zephyr Tech Talks. And today is kind of a special one. Some of you may be aware that just a few days ago, the new major version of Zephyr was released, Zephyr 3.5. And we have tons of guests and tons of people today to actually talk more about what's happened in the last 4 months. We do releases every 4 months, and every time it's pretty packed. So I will bring everyone on screen. There's quite a few people, and I know that all of you watching us today are also joining us from all over the world. So like we always do, please feel free to already engage on the and share on the chat, in whether you're joining us from LinkedIn or YouTube. Well, if you're watching the replay, you can also comment, that's fine. But if you're watching us live, please let us know where you are joining us from. I'm joining from France myself. And pulling everyone on screen, we have, how many people is that? 7, 8. Did some people drop actually? Yeah, no, I think we have everyone. So, Anas, why don't you go first? Tell us a bit about who you are, maybe what you do for the project, and where you're joining us from.
Hi, Anas Nashif. I work for Intel, and I'm joining you from Montreal.
Nice. Tom.
Yeah, hi. Tom Burdick here. I work for Intel with Anas. It's a great team. Yeah, I do quite a variety of things for the project. I'm the DMA maintainer, the I2C maintainer. Recently added this new extension subsystem, and working a lot on sensors. So quite a few things.
Nice. Bjarki.
Yep, I work for a track unit. I mostly deal with modems and also maintain the RTC subsystem.
Nice. Fabio?
Hey Ben, I'm Fabio Baltieri. I work for Google. I'm based in Dublin, Ireland. I was one of the release owners for 3.5, and I maintain the input subsystem and just contribute to a bunch of random stuff.
Alberto?
So I'm Alberto Escolar. I work for Nordic Semiconductor from Copenhagen, and I'm the maintainer of the native port of Zephyr and of the Babel Sim simulator that we use for the Bluetooth testing.
Nice. Fabian?
Yeah, Fabian Blatz. I'm joining you from southern Germany, and I work at a small kitchen faucet producer who's dabbling in IoT. And since, I guess, now 3 months is it, I have been the maintainer of the LVGL module.
Nice. And Johan?
Yes, hello. I'm Johan Hedberg. I work for Intel. I'm based in Helsinki, Finland, and the maintainer for a couple of subsystems in Zephyr for a long time for the Bluetooth subsystem, and then also looking after the, Intel's platforms in Zephyr. And together with Fabio, I was also a release manager for the 3.5 release.
Nice, thanks. And yeah, I don't know if you guys all saw that, but it's actually hard to put everyone on screen from the audience. We have people, again, from all over the world. Lots of people from Brazil, it would seem. I saw France, I saw India, Germany. That's pretty cool. So people watching us, you just did a quick test of whether the chat functionality worked. It does work, so feel free to use that anytime to ask questions to us. That's actually the one point. I think we subtitled the session for today, Ask Us Anything. So as a way maybe to get things started, I will just like put it on screen, the blog post, the announcement blog post for the Zephyr 3.5 release. There's a lot that's happened, right? And it's always hard actually to sort of summarize what's been going on, because there's lots of work that has to do with stabilizing the code base in the first place, and it doesn't necessarily mean new features. It just means stabilizing stuff. But that being said, there's tons of new stuff that's been done and added to the release. If we were to look at it in numbers, and take it with a grain of salt. It's always it can come across as maybe vanity metrics, if you want to call them that way. But it's actually interesting, I think, to look at how much happened and how active the community has been. If you do the math, like having like something like 2 commits per hour, it's a lot. Like, it depends whether the commits are big or not so big, but having this kind of sort of like steady stream of contribution, steady stream of new maintainers, new contributors over time, I think it's pretty impressive. And yeah, we will go through the list. Maybe some of you in the chat and some of you watching us, you've been using Zephyr for a few months, a few years. Maybe there's a few things that you already spotted in the 3.5 release notes that you think are particularly interesting. So feel free to share that, and maybe I can actually ask our participants what's their favorite bit from Zephyr 3.5, and we might get to spend more time. Some of us brought the demos, and in any case, like should people have questions on some of these highlights, we're here to answer them. So yeah, maybe let's start with Anas. Like, is there anything that particularly sort of like caught your attention, or that something like a long outstanding issue that finally got tackled in 3.5?
Yeah, there are many things that were introduced in 3.5. A lot of things that are still experimental and so on. And I mean, you know, I don't want to start counting. There are so many favorite things, but the one thing that is actually just yesterday night, I was trying to fix a bug, and this new feature helped me immediately. I was able to see that immediately what the bug is, and this feature was introduced actually by Fabio, yeah, who's on the call here as well, yeah. So, and this is basically the whole thing with init levels, yeah. Can I share my screen?
Sure. Yeah, I can put you on screen. And then I think Fabio also has a demo actually, so we can probably do both.
So basically, it's very simple thing to invoke and get running, and I will show you the bug that I discovered. This is the new init levels target, which shows you basically the boot process and what happens, you know, during the boot sequence. And this is like a bug on some Intel hardware, and you know, I looked at that and I immediately saw what the problem is. Yeah, all of a sudden we have these guys here. The UART is started like in post kernel for whatever reason. Much longer after the logger, the console, and so on, and that basically was called like having a few tests to fail. Yeah. And and I was able immediately to fix that. I submitted all the bug. This thing has showed many other issues that Fabio actually went and fixed before this was introduced. But this is a great, obviously, this is the current state of things. There are a lot of things coming, and the things that we are doing with regard to the boot sequence and the initialization process that would be, you know, possible to debug and see the progress using this new target. So this is like really since yesterday, well, much before, but since it's actually helped me find this bug, one of my favorites. Yeah, top one. Let's put it this way. Thank you, Fabio, for making this happen.
Cool. Nice. All right. Tom, how about you? And I think, this is maybe a loaded question because I kind of know what you've been working on. So why don't you maybe tell us a bit about some of the stuff you've been working on? Like you said, you have tons of stuff on your plates, including sensors as well. But I was, and many people were super excited to see this finally sort of unlocked the ability to load dynamically code into a Zephyr running application. So maybe can you talk to that a bit?
Yeah, I sure can, and I can have a little demo. Let's see here.
Oh, nice.
Maybe. Let's see if I can share a single window. Is it working? All right. So let me just talk about the features. So it's been a long-standing issue that people have wanted to be able to, change or modify the behavior of their firmware at runtime. To be able to load modules. A lot of operating systems call them modules. Zephyr already has sort of a term, modules being used for WES, so we changed it to extensions. And yeah, so extensions let you do just that. You can build a little, I'm just going to build a little Hello World program here. It's just one off, and we can take a look at it here. It's very small. It's just gonna. So I mean, this is just kind of like a little independent C code, right? It just has a single external function, a number. So somewhere there's a print K function available to me. I have no idea where, and I'm just gonna print out some stuff. But I mean, like this is really, it's gonna build an ELF file for me. It's not a whole program, right? It's just a little small part of a program that you can load up at runtime and extend your firmware with. So it's kind of the simplest example of what you could do with this Hello World, right? Yeah, so it's quite small. We can kind of take a look. I have it on a screen here. I can, did I already loaded it? I might have already. No, I did, but we can load it again. Hello 2. And so yeah, I paste in a big hex blob. This is just like the hex dump of that ELF file. And it loads it up. You can call functions, right? Hello 2, hello world. And it's going to print it out. And that's fantastic. So, I mean, this is really simplistic, obviously. It's not doing a whole lot beyond, I create a little independent ELF file, load it, run some functions in there. But that's sort of the beginning. And, it's an oft-asked for feature for a variety of reasons. I mean, maybe you have like a small kind of core firmware blob, and then you have like a bunch of independent pieces stored on flash or maybe coming from elsewhere, and you want to be able to swap them in and out. So sort of like processes, right? But not quite. Some people have, maybe a board layout or that they've, or maybe several board revisions, right? You don't want to necessarily load up all the software that you've written to cover all these board revisions. Maybe you want to just kind of load up the pieces that are necessary. So closer to maybe loadable drivers. I mean, that's maybe a long-term possibility with this. But today, very simple Hello World type functionality with a lot of caveats and limitations. But it's a first stab, and it's getting us started down that path. So yeah.
That's really cool. Thanks for sharing. If folks in the watching us, if you guys have questions, feel free to already ask them. It looks like the arrangement has changed. Bjorky, looks like you're next. We had you not so long ago, so we kind of know what you've been up to. But can you share a bit maybe on what really what you find particularly interesting in 3.5, including maybe stuff that you directly contributed to?
So, of course, I'll be a bit biased because I spent a lot of time working on the modem subsystem. But honestly, the additions of the modules for the modem subsystem, which are nice, are only part of, let's say, the fun that has been going on in this release. Essentially, the PR or the actual work going into adding these modem modules took about half a year or so. And it was a collaborative effort with multiple just developers who were interested in adding to it and just had a passion to work on it. So I think the modems themselves being there, that's very nice. It's a nice foundation for modems. But the cool thing is the actual work that went into it and the collaborative effort behind it. I think that's the nicest thing about this release, the amount of collaborative effort and enthusiasm.
Yeah, I agree. Cool. Fabio, I think you also have a demo and has spoiled some of it, but maybe you can actually for folks who are not necessarily familiar, and the question also applies to Johan. I mean, you were a release manager for 3.5, so maybe can you tell us a bit about what that actually means, because it feels like it's a lot of work, and maybe, I mean, some people who are directly contributing to Zephyr, maybe they understand slightly better. But yeah, just in a nutshell, what's been your role as a release manager for 3.5?
Yeah, so the responsibilities for the release manager are actually written in the documentation. It's fairly well defined. And it's essentially two parts, and it's mostly coordination. So the first part is during the integration period is to run the release meeting, do bug triaging, keeping an eye on the continuous integration, all that sort of stuff. And then when the stabilization period happens, that is cutting the various RC, there's a bunch of stuff related to submitting the actual tags, and also trying to make sure that no new features gets added and things get fixed, that sort of stuff. So it's really a lot of coordination work and keeping an eye of all of the incoming traffic of changes. And there's two release manager, which works pretty well because it means you can go on vacation and have the other person cover for you. So in this situation, it worked pretty well with me and Johan. Do you want to add something, Johan?
No, I think that pretty much covers it. So we have a whole release engineering team, of course, that supports the activities that we try to coordinate. So just looking after like the bugs coming in, making sure they have assignees, and checking that important pull requests can get merged eventually. But yeah, you pretty much covered everything that's involved there.
Nice, cool. So yeah, Fabio, maybe back. I mean, unless you have other highlights, but I think one that you wanted to cover was around this tooling that got added around initialization levels. Do you want to like maybe take it a step? Yeah.
Yeah. So well, for 3.5, my pick would be the changes, the modernization in LVGL. So I would put Fabian on the spotlight, but I'll leave it for him. But I just want to say it's great to have the module maintained again. And Fabian also did a bunch of upstreaming to the main LVGL repository. There's now some Zephyr specific documentation there. So it's actually great to have, but I'll leave the details to Fabian. But yeah, I do have a demo about a feature that I worked on. So this is for validating the device initialization sequence at build time if possible. So I put together a small application. This is an out of tree application. I have a simple I2C device connected to an I2C bus. I'm running this on a NRF52DK, but it would run anywhere. And I am building against 3.4. So I'll just do a build. And I didn't show the code. So the code is just, I am defining the I2C device with the standard macro, and I'm just initializing it. And I forgot to do the device is ready check because I forgot. And I initialized with priority 1 because it sounded like a good idea. So I'm going to build it, and I'm going to flash it. And 1 second. And look at that, it failed. And the device is there, the code is fine, but I get an error on my I2C, right? And then some obscure error on the back. What's happening is that I'm trying to use the I2C, but before it's initialized, the internal state is whatever the driver has. I could get an error on some other board. This just locks up, or you could try to reference a null pointer and breaks in some various ways. This can take some work to debug if you don't know what to do. So let me switch to 3.5. All right. Update. I'm going to rebuild exactly.
Yeah, actually, I have a quick question before maybe it builds and stuff. One thing that I wanted to ask you all is, what IDE or what tools are you using to actually write your Zephyr code? Because I saw some Vim there. I'm a VS Code guy myself. Like what else? I think Bjarki, I was seeing you using VS Code the other day. What else? Are there Eclipse people out there or anything else? JetBrains.
I'm happily using Eclipse.
Wow. Nice. Okay, cool.
I'm using Vim.
Nice. Okay. And I would be actually curious also in the chat, like YouTube, LinkedIn people, what is your IDE of choice, or maybe no IDE? Okay, so what are we looking at now?
Yeah, so I've rebuilt the same code against 3.5, and now I'm getting this error. And what this is telling me is that I have device, my device node, which is under I2C, SOC I2C, and test I2C device, is trying to initialize in position 1. This is the second call of post-kernel. And this is telling me that, hey, the bus, SOC I2C, it's initializing after that. So this actually fails the build and is not even going to let me try and flash the application because it knows that it's going to fail in runtime. So now what I'm going to do, I can just change the initialization priority to 99, put it at the end, and then I can rebuild and the application build correctly. I don't get the error anymore. And if I flash it, this is going to run, and I'm now, it's going to work correctly, and it's going to read from the I2C device correctly. And to visualize what is going on here, you can run the command that Anna already showed, which is init levels. And in this case, these are the two functions that have to be in the specific order. And the script checks that they are in the right order for you based on the device tree. That's it.
I want to applaud, but I think it will sound weird.
So, sorry,
what's that?
I would like to give an applause because it's very cool, but I don't think it's going good through the microphone.
Oh.
Yeah, no, it sounded all right. But I agree, and it's actually it's way more than just having the init levels target, like showing it to you as an FYI. It's actually really integrated in the build system, which actually I didn't realize until you shared your demo with me the other day. So it's really cool.
It's a nice debugging feature, and actually credit where credit is due. This feature of printing the init level is actually an idea of Bjarki that suggested it when I was doing the initial script for doing the check. So thanks, Bjarki. That was a good idea.
You're welcome. I did 0.01% of the work.
And I think we have a tie between Vim and VS Code in terms of people who are watching. I certainly saw a lot of both, but then a bit of C-Lion as well. Nano, but I was just kidding. Anas, looks like you're a Vim person. Cool. Moving on, let's put everyone back on screen. Alberto, do you want to tell us a bit about this sort of revamp, I guess, of the native story for Zephyr in the form of the native simulator? You actually already have, I don't know if you saw that, but you actually already have a question. I will briefly put it on screen, but maybe you can actually give a bit of context as to what's the native simulator. But as soon as you've done that, maybe you will be able to answer Scott's question that we will, I will put it back on screen. But can you tell us about this?
Yes, so the native simulator is effectively an improved version of native POSIX. Native POSIX was introduced long ago, 6 years ago. And it was something that was simple enough to get us very far, but had some shortcomings that we were aware from the very beginning. You cannot build with an embedded C library in native POSIX. And that, you always build with your host C library. And that means that we have some symbol conflicts. You do not know sometimes if you're calling into your host C library or into some Zephyr functionality. Or what? It can get confusing, let's put it this way. So this is something that we have now effectively fixed with the native simulator, as you can build with an embedded C library. So all your embedded code, so your application, the Zephyr operating system, and your embedded C library can be built together. And they are built as a sort of library that then is linked with the native simulator runner. And in this way, your code is much more isolated from the point of view of what you are compiling together, so you don't get confused of what you are linking with what. But at the same time, you still have access to the host for debugging and so forth. So you can run your code in Valgrind or in GDB or with whatever you want, and get coverage reports and so forth, just like before. You still have the option with the native simulator of linking using the host C library. That's still possible also, if you want to do that.
That's okay.
Yeah. Then another thing that the native simulator enables is having asymmetric multiprocessor targets, simulated targets, and that's something that we have already in main right now with the NRF 5340 simulated. This is now a simulated platform where we have actually two microcontrollers running at the same time, in your workstation as a workstation executable. And that allows you to debug all this kind of interaction between the microcontrollers and so forth, which is actually a very nice thing. So with regards to this question of if it is possible to have both the TTI and the PTTI at the same time, in principle, you are able to build them. I never tried to use them at the same time. So that is actually a tricky question. We will need to give it a try and see if that combination works reasonably well. But you can always, give it a spin and see what happens.
Cool, thanks. All right. What else? I think we are up to the LVGL part of the release. If I am to put back, let's see real quick if we missed anything. We will want to talk to this one actually at some point. We might have one of the main person behind this change joining us, hopefully for the second half of the stream. But if not, we will come back to it and talk to what this means. I think I even have like a short, hopefully meaningful demo native simulator, which is so. A big change, and Fabio, you briefly mentioned that, is the fact that it's now much easier than before to use LVGL. And Fabian, I'm going to put you on screen because you've really helped make that happen. Can you there's tons of applications for Zephyr, obviously, and lots of people would build applications that have no form of like human interaction whatsoever, or at least like not to the point where there is a human, like an HMI or a GUI. But many people do care about having a GUI, and in this case, there are some interesting open source libraries out there. I think LVGL is one. So can you tell us a bit about like maybe just what you know about LVGL in general, what you're using it for, maybe as a either in your company or for yourself, and some of the work that's been done for 3.5, because it's now really cool, all the stuff that's made it into the release.
Sure. So as some of you might know, LVGL is abbreviation for Light Versatile Graphics Library. So essentially what LVGL does, it takes care of managing a draw buffer or multiple thereof, and essentially drawing widgets to the screen and coordinating like user interaction, touch input, and that kind of stuff. And it takes care of the invalidation, but everything aside from that, so actually rendering the drawing buffer to the display, that's a portable aspect of LVGL. And that's also essentially what we are doing in Zephyr. So we are using the Zephyr display API and essentially use that for managing how we write the display buffer to the actual device. And what I've been doing for this release is adding new pseudo devices. So until 3.5, there was only a K-scan input device, which used the old K-scan API and received events from that. But the thing is, the old K-scan API was essentially misused. So it should be used for keyboard scan matrices, but we used it for display touch input in this case. So I essentially took what we already had and streamlined it, and also added two new pseudo devices. So one for the encoder and one for physical buttons. And that would be it from my side.
Nice, and I think there's also the fact that it's now because I mean LVGL has some like a really rich toolkit in terms of like tons of widgets, etc. And I'm going to try and put that on the screen. Yeah, hopefully it will work. Like it's now, and the instructions can be easily found in the documentation. It's now super easy to actually run the. Oh, it's really blurry. I'm sorry about that. We'll get there. Yeah, all the demos. Yeah, the autofocus is really messing up. But all the live, all the demos that are shipping with LVGL, there's now a dedicated code sample that you guys can just like, yeah, just build a sample, and as long as your device has a display, then well, it will display stuff. If it has a touch screen, then it will work as well. If it has rotary encoders, that would be an option as well. But yeah, it's actually really blurry. Sorry about that. And this particular display has a glitch. I don't know if you see that, but sometimes when it refreshes, it's acting weird. But yeah, long story short, there's a new demo, which is more than just a Hello World now. It's really the full-blown LVGL demo for having a showcase of all the different widgets. There is a benchmark, I think, as well, that you can use to kind of get a sense of what's the frame rate that you're getting on your particular hardware. Yeah, and anything else, Fabian, that you have planned for the future? I guess one thing is trying to stay sort of aligned with the upstream version of LVGL and making sure that whenever people build an LVGL app in Zephyr, they pull whatever is the latest version of LVGL. But anything else that's on your plate?
Yeah, so one big thing will be the release of LVGL 9, because there was a bunch of work done in regards to performance. So essentially, the way rendering works is that now the workload will be dispatched across multiple, let's say, helper threads. And they added a whole nother OSA layer to LVGL. So we will need to implement that one as well, so we can improve performance even more. And also regarding the pseudo devices, if you noticed, only 3 of the 4 ones are implemented right now, and the last one, the keypad one, is still missing. And I have already lined up a prototype for that and need to clean it up, and soon enough you will also be able to use some sort of keyboard to actually fill in text into text areas and that kind of stuff.
Nice. One thing, it might be completely off and random, but one thing that I was thinking the other day is that I would love to see, if that's even possible, a shell backend for LVGL, and you do some kind of magic shortcut, and assuming that you have like a device with a screen that's large enough and putting all the potential security considerations aside, but like when you are in actual debug mode, being able to pull like an actual shell and being able to interact with the Zephyr shell, both like visualizing the output and potentially typing stuff right from the device. I'd like to see that.
Yeah, that should be easily possible, I guess. The text area provides like plugin points for sending and receiving data. So
yep. Yeah, just a thought. Maybe I should just log the issue to make sure that we keep that on the radar. All right. Let's see. Johan, what's your highlight for the release? And after that, we can probably go back to the blog post. There's still the Picolibc discussion. Maybe you want to talk to actually to Picolibc or anything else really that would have been a highlight for you.
There are lots of things which are really nice with the new release. Picolibc is definitely one of them, and it looks like we're getting some quite nice footprint improvements, reductions with that, and potentially more to come in the future. The one thing that's actually mentioned in the release announcement, one feature which is related to what I'm spending quite a lot of time with Intel platforms, is the ACPI CA library, the ACPI component architecture library that we integrated to Zephyr for 3.5. And it's basically an operating system agnostic open source library. It's used by FreeBSD, by Linux, so it's well proven. And the ACPI specifications themselves are quite complex, and what you will need to implement is quite a lot of code, and probably prone to bugs as well. So it's nice that we can use an existing implementation for that. We're not taking a lot of advantage of it for now, so you could think of it that we have kind of the initial base support there now, but it acts as a good platform to start building more advanced ACPI features to support platforms with ACPI.
Nice. Okay. Okay. So yeah, let's talk maybe a bit about Picolibc then, because and anyone wants to talk to Picolibc, I have a demo that I can show to see sort of one of the end results, which is a significant improvement in terms of minimizing the footprint of an application. But I don't know, Anas, maybe do you want to, picking on you, do you want to talk to the history of like what's been the, because there's been several options. What's that?
We have Keith. We have Keith on the comments. Yeah. In the comments, Keith, I can see
join
him.
Us, like open your emails and just join. Use the link to join us live, and I will make sure if that's okay for you. And I know it's super early, but yeah, Keith is basically. Oh, are you waiting in the studio? Oh, I couldn't see you. You were in a different line. Hello, Keith. There you go. Awesome. Super cool. That and I don't know how long you've been there. Sorry about that. You were off screen for me. So yeah, welcome, Keith. You're the man behind Picolibc. So why don't you tell us maybe about what is Picolibc in the first place, and then what's the work that went into 3.5?
Absolutely. So Picolibc started as a project for some rocketry and satellite embedded work that I do when I needed something a little smaller than NewLib that could run on devices with only 4 kilobytes of RAM. And so I started with an older embedded C library that was kind of terrible, and really wanted to use some of the functionality in NewLib, but NewLib was just too large. And so I took the core of NewLib, kind of the math library of NewLib and the string functions, and then bashed in the AVR standard I/O bits, which were super lightweight, designed for the 8-bit AVR microcontrollers, and have been working on it ever since, improving standards conformance and getting it tested. So probably the biggest part of Picolibc is that it actually, the CI system runs the entire library through a huge battery of tests at every commit on a huge variety of embedded platforms. And so one of the big pushes for 3.5 was to get as many of those tests running across all of the Zephyr SDK toolchains as possible. And so now Picolibc testing in CI actually uses the Zephyr toolchains, currently 1.6.3, 0.1.6.3, and I'll keep updating that. And so now Picolibc is essentially testing all of the internals of Picolibc with the Zephyr toolchain and all the Zephyr targets, which is really helping broaden the test coverage and fixing up some minor Picolibc issues. And so I've been catching a whole bunch of bugs in Picolibc, which was really the goal of mine here, was to get my C library running better on embedded systems.
Nice. Okay. And there is actually a question that's a really good question that I'm just putting on screen. How far along, or like what's the differences rather between NewLib Nano and Picolibc?
So NewLib Nano is really not significantly different from NewLib. It restructures some of the shared global variable data state to be a little bit smaller in some cases. But the big difference between NewLib Nano and Picolibc is that Picolibc doesn't need an allocator, and it doesn't use any RAM in its default configuration, or a tiny bit of RAM. And so it's much lighter weight in memory. And the other significant difference is that Picolibc is tested on your targets, whereas NewLib is only ever tested on x86. And so all of the embedded, custom embedded code for all of our targets that has assembly code for the targets is tested regularly in Picolibc. and is now standards conformant across all of those platforms. So if you absolutely want to make sure that your C library is standards conformant on the target platform that you're building for, then only Picolibc gets that kind of testing and has the fixes necessary to actually make that work. So things like IEEE conformance in the floating point libraries, things like conformance with the printf specifications, and all of those other things. So the big difference here is that. And of course, code size. Picolibc. You'll notice that the benchmarks for code size for Zephyr have kind of dropped by a couple kilobytes with the transition from the minimal C library to Picolibc. The difference between that and NuLib or NuLib Nano is even more dramatic. So if you're interested in tight code running in very little ROM and very little RAM, then Picolibc is a good answer for that.
Nice, thanks for that. Yeah, let me see. I'm trying to see whether my demo is in a showable state. It probably is. Let me try and share my screen.
Hey, can I mention something?
Yes, please.
Before we set it up. So yeah, thanks, Kit. So listening to the Picolibc story reminded me of something that I wanted to say about the release. Every time we have a release, there are some tree-wide gigantic effort that somebody carried on, like in this case, switching the default C library. And quite often, like, there's always a lot of work, and quite often there's not much glory in finishing those. And I think it's worth mentioning that in 3.5 we had Daniel Lang that did that enabled the shadow variable warning by default, and to do that he had to fix a lot of code, send a bunch of pull requests, including cleanup modules. It took a lot of work. So yeah, props for that. And another one that we saw lately is from you, Ben. Like, you cleaned up a bunch of documentation issues, like small snippets, wrong code, stuff like that. So yeah, thanks everyone who did those work. We really need them, and it's a lot of work. So yeah, thanks.
Yeah, thanks. And actually, thank you to everyone watching us who might have been involved as well, like documentation-wise. I'm seeing more and more people doing the right thing, which is whenever you find something that feels like it's just a typo, like a super minor glitch in the documentation, send a PR. And I see more and more people doing that these days. And it's always nice to see. And doesn't have to be code. You don't have to contribute code to help make Zephyr better. Let's see. I think before the demo there were there's other questions, but I think maybe you just answered this one, Keith, directly in the chat. NuLib and NuLib Nano seems to have permissive licenses, and Picolibc seems to be GPL. Like, can you maybe clarify that point, Keith?
Yeah, absolutely. I did clarify it in the chat, but it's worth mentioning again. So one of the things that I did in Picolibc was actually remove all of the GPL code that NuLib and NuLib Nano use that is actually built into the library. It's not built in for most embedded targets, but it is in the repository, which makes the licensing somewhat complicated to understand. For Picolibc, there's actually an extensive document at the top of the file, copying.picolibc, which indicates the license in every single file in the repository. And I went through a bunch of work to make sure that those were all cleaned up. One of the things that I did in particular for the Picolibc release was to change all of the 4-clause BSD license code in the repository back to 3-clause by getting permission from the authors of that code. So actually the licensing in Picolibc is quite a bit clearer than the licensing in NuLib and NuLib Nano, because the 4-clause BSD license is often problematic in a lot of environments. And so there is a couple of pieces of GPL code in the Picolibc repository, and that is just a couple of test cases that are run during CI, but none of the GPL code is built into your application. We had to actually go through that in some detail when working on the Picolibc integration into Zephyr, because of course Zephyr doesn't want to have GPL code getting linked into applications, because that would be problematic for a lot of device builders. And so we made sure to get the Zephyr committees on board with a licensing situation in Picolibc before taking as a hard dependency for the building Zephyr applications.
Nice. Okay. All right. Let's see for the demo then. How about I put?
Does your demo work?
I think it does. Do you have one that you want to?
I don't have a demo. No.
Okay. Yeah. Let me try and. make the point of what's changed. So we're looking at Hello World, which I'm going to build against a like it's really literally just Hello World. If I am to build Hello World using the historical, supposedly really small minimal libc, we will get to a small-ish footprint, but let's see about that. All right, yeah, we get about like 15 Ks of on this particular STM32 target. We have this footprint. So even if we were to stick to just like minimal functionality, I think it's, so remember 15.3 kilobytes of flash. So even if we don't do more than that, I think it will be smaller with Picolibc. But then when it gets really, yeah, it gets slightly smaller. But when it gets really interesting is when you start pulling slightly more than just.
Can you remove the videos to the side because we can't see the bottom?
Oh yes, thank you. I was not paying attention. Yeah, I will, and I can even put myself on screen or whatever. How can I actually do that easily? Let's see. Bloop, bloop, bloop. Sorry about that. Doing too many things. Where am I? I'm here, and this is, yeah, thanks for that. Much better. All right, where was I? Yeah, what if I want to do slightly more, not much more, but this particular, this would not build with minimal libc. Like as soon as I start using slightly more than just print and A2I and whatever, this will simply not build. I should have trusted me. I didn't have to necessarily show it. But then what if I were to build with Picolibc? It will be just a tiny bit larger than before. I think we will still be looking at 15 something kilobytes. Let's see. Yep. Only that bigger, like, and we could look at how much footprint we got from SQRT and SYN, but that's really not a lot. And if we were to build the same with libc nano, so remember again about 15 Ks. How about libc nano? I think it will be larger. I think we're looking at 18 or something, which, I mean, it's a Hello World. I'm hardly changing any code, but you can sort of tell what would happen if you have a much larger code base. And this is where my demo failed, or is it? It should have been different, obviously. Yeah. But yeah, like if
you just probably need to clean your build. I don't know if you are.
Yeah, I think I am. But yeah. Demos. Try it actually with something that's not a Hello World, and you will see that the difference is really significant.
Maybe
and
you can show the dashboard with the drop in the.
Yes, that's right. I wanted to. Yes, exactly. Let's do that.
While you bring this up, the minimal libc was never there to, like, minimal is not for footprint. It was minimal. Just give me what I need from the C standard. Yeah, I mean, that was in terms of implementation and coverage. It was not about footprint. Yeah, I mean, obviously, it was a minimal implementation, but so Picolibc actually is doing a great job there. That's really great. So you can show the graphs, which are actually very impressive. Yeah.
Yeah, I'm pulling it right now. And for people who didn't realize, like just before, like there are targets in West that you can use. Like whenever you're interested in getting the ROM footprint of your build, it's there, right? And like what I was showing is just available in vanilla Zephyr. It's not like any kind of special tool. Let's see. And similarly, for folks interested, there is a dashboard available in on stats.zephyrproject.org, which tracks many things like number of open issues, number of open pull requests, and whatnot. And that's what Keith was mentioning earlier. It does, and it has for the past several years, it does track how the footprint of some typical applications evolve over time. So it's actually interesting to see that although the kernel and the Zephyr ecosystem is getting richer and richer, the footprint hasn't grown all that much over the years, but it's actually dropped quite significantly for typical use case, which I think the footprint application, it doesn't do a lot. I don't remember exactly what it does, but it's certainly pulling the HAL from the whatever a device it's using, and a bunch of subsystems, and it's dropped from about 18Ks to about 15 something or 16 something, and it's for a really small application. I think there might be some slightly more substantial apps there. This one is not so clear. We're looking at something that's much larger, so there's still a drop in the form of several Ks. But yeah.
The footprint is just like a dummy application that try to build everything, So it doesn't work if you try to run it, probably, it just tries to pull as much code as possible and to see best to cover everything. It's just a test application, anyways.
Yep. All right, so we're actually reaching the top of the hour. So I don't know if maybe you guys know better. I don't think we missed any questions from people in the audience, but if you have more questions, now is the time. Otherwise, it will be more asynchronous, and you will be asking in the YouTube comments, and you won't get a chance to get the answer live. But guys, is there anything else in the release that we may have forgotten? One thing that's always happening, and it's hard to sort of name and enumerate all the new boards, all the new drivers that made it, but there's certainly some interesting ones. Just a few weeks, I think, before the release, someone ported Zephyr to Raspberry Pi 4B, as in that. I wasn't expecting that. You would typically run Linux on this Cortex-A pretty big MPU, but it's now running Zephyr, or at least a super minimal version of Zephyr. Anything else that we may have missed? And if not, what's on your respective plates for 3.6? Is there already some big, I think sensor-wise, there's going to be some, hopefully some fresh blood and fresh discussions, right? To sort of maybe address and do something similar to what's been done with modems in the 3.5 timeframes, in terms of addressing the technical debt, for the lack of a better word, in terms of making sure that we are really sort of future-proof in terms of being able to support new use cases, etc. There's something like that happening for sensors, right? Tom, do you want to talk to there's a new working group, right?
Yeah, absolutely. There's a new sensors working group, kind of stemming out of a couple of things. This goal of improving the sensor API, the driver API itself, as well as adding a sensor subsystem to enable sort of directed graph processing nodes of sensors feeding basically a kind of a virtual sensor that maybe generates sensor-like data that feeds maybe more things, and so on and so forth. And that's incredibly useful to Intel and Google for the devices that we kind of make, but also many other people. I was actually really excited to see one of the more recent contributions and projects that sort of being built around Zephyr is this CogniPilot project around they're doing basically a kind of a PX4 drone controller, and they're doing a lot of the same. They have a lot of the same needs for a newer sensor API, as well as kind of potentially as the sensor subsystem and building around that. But they're not the only ones. I think people have sort of handcrafted their own sort of changes or sort of ad hoc hacks to the sensors API in their projects to both enable certain features that aren't really clear how you might do it in an upstream driver, but also kind of crafting their own sensor subsystem of a sort, right? I mean, I know that for example, Vestas has kind of some interesting use cases around the sensor API, especially related to all those things. So yeah, we're targeting 3.6 for an improved sensor driver API and a subsystem that all integrate really well together. Have some samples, try to cover a variety of use cases, both low power, low low frequency polling type sensors, but also the really fast, so much faster sensors that maybe might be used for drones or, industrial, robotics and things of that nature. So it's pretty cool. I'm excited.
Yeah, agreed. And as the TSC chair, like, is there anything like sort of high level items, maybe in terms of like all things APIs, right? Like there's lots of work being done to make sure that we document our APIs better. We make sure that like from one release to the other, it's really clear like what may have changed, things like that.
Yeah. So I mean, for everyone to know, so now we have just 3.5. Next will be 3.6. We have two new release engineers doing that. Maureen Helm and Briggs from Vestas. Maureen from from analog. Yeah. Digital. And yeah, that's all. So, but after that, we are getting 3.7, which is going to be the LTS. And right now, and as Fabio has said earlier, there's a lot of work that goes into the release that is not really a highlighted feature, mostly clean up and so on. And we have been doing that over the last few months, and we will continue doing that. And mostly it's going to, and that's also stuff that Benjamin has been collaborating and making progress with, is like the documentation of the APIs. But more than that, making sure that our APIs are, beside them being documented, that we distinguish between public and internal APIs, how we actually expose the APIs, how we have like one single source of truth for the API, so there is no confusion about what people should be using, for their own applications or driver support or hardware support. So this is like something that is going to continue. I have been, doing a lot of work with this regard, cleaning like many of the headers and so on, but also we are like, you didn't like show the code checker thing, but we are like also trying to add more CI in place and workflows to support enforcing some of the coding guidelines that we have in place, and making a lot of advancement that might not appear as a feature at the end, but would help stabilize and make sure that people using LTS next year when it's released, they can rely on it for a longer period of time in terms of like stable APIs and so on. Yeah, so that's like really one of the major activities we are focusing on. Hopefully a lot of that will go in 3.6, but next year we will do more to stabilize the APIs and the interfaces that we have.
Nice, thanks for that. So yeah, we're reaching the top of the hour. I think Fabio, and that applies to Bjarke as well. One thing that you just mentioned in the chat, and I'm certainly looking forward to that one as well, is kind of like the next step after revamping the whole modem stack, is adding support for GNSS. So that this one will be certainly really cool. And I think it's pretty much ready, right? Right, guys? Bjarke and Fabio, sorry. It's already, the PR has been there.
A few more reviews, I guess, but it's looking good. It's actually pretty clever. So invite everyone to look at the pull request. Thanks, Bjarke. Long time in making.
That's why we put you in the center, Bjarke. You're clever. You're in the center of the screen. With that, I think it's time. Keith, I think you had one last question in the chat. If you want to maybe just answer it directly on YouTube for Anuraj, but it was asking about things to consider with respect to reinfancy issues. But since we need to wrap things up, I just want to make sure to plug our next episode. So we're still doing those on a bi-weekly basis, but as many of you, and Keith, actually, you agreed to present Picolibc in more details. I think we're looking at December the 8th off the top of my head. So Anuraj and others interested in Picolibc, you can already take note, and I will make sure that it gets announced shortly. But yeah, we talk again in 2 weeks' time, and maybe after that we will switch to weekly cadence. Make sure to subscribe to the YouTube channel to not miss future videos. And I will put everyone back on screen to thank you all, guys. I hope this was a good use of your time. I think the community really enjoyed getting those updates directly from you. People who were watching, if you're not aware or if you're still a bit shy, remember that it's just like a few clicks away to engage on either Discord or on GitHub if you have questions, things that you feel are features that are missing, issues, whatever. There's lots of people that are either on screen today or that we are not joining us today that are willing to help should you have any questions. So with that, thanks again, everyone, and we'll talk again in 2 weeks. Bye.
Thank you. Bye.